One of the more difficult pieces of function analysis is beginning with either a derivative or a second derivative and using that to inform what you know about the original function. So in this first example, what we have is a horizontal line. It's the derivative going through 2. We need to draw a picture of a possible function f of x. Now one thing that's true, because the derivative is positive everywhere, well then we know that f of x should always be increasing. The other thing to notice is that since f prime of x is a horizontal line, then its slope will be 0, which tells us that f double prime of x is 0. And that means that the function can display no concavity. So we're expecting a function with no concavity at all. That's always increasing. And since f prime is 2, that means it's really just a line with a slope of 2. So it could pass through the origin and have a slope of 2, which means it's going to be going up 2 and right 1. And so here's one possible graph of f of x. Right, and if you think about the equation, this would be f of x equals 2x, and its derivative would be 2. Notice that another possible equation would be 2x plus 1. It would have the same derivative. Let's consider part B. Now in part B, what we have for the derivative is a line. It's not a horizontal line, it's just a line, and that's the derivative. And some things to note is that the line is negative on the left-hand side of the y-axis and positive on the right-hand side of the y-axis, which means that since the derivative is negative, then I would expect the original function to be decreasing. And where the derivative is positive, the original function should be increasing. Some other things to notice: since the derivative is a line, and that line has a positive slope, what I know is that the second derivative must be positive. And since the second derivative must be positive, I would expect this graph to always be concave up. Right, so some things again: from negative infinity to 0, the graph should be decreasing. From 0 to infinity, the graph should be increasing, and I would expect this to always be concave up. So one possible graph, then, for f of x would be something that's decreasing from negative infinity to 0, and increasing from 0 to infinity, and always concave up. And that would be some type of parabola. Now this is f of x equals x squared as a possibility. Notice that its derivative would be 2x, which would be the line that we're looking at. Right. Some other things to notice from example A and example B: a horizontal line, if that's the derivative, then the original function would be a non-horizontal line. And a non-horizontal line, if that's the derivative, the original function would be something squared. And that should make sense if you just think through the power rule a little bit. Let's consider C of this. What we have for the derivative on C is what appears to be maybe a semicircle or perhaps an upside down parabola. This is a picture of the derivative. And one thing I see about the derivative is that it's always negative. And since the derivative is always negative, or 0 at a single point, then my original function should always be decreasing. Except at x equals 0. Right? It's decreasing wherever x is not 0, and at 0 it will not be decreasing or increasing. So it'll be a place where there'll be a horizontal tangent. So that's something that I can see here. I can also recognize that, I'll do this in red, that if I were to consider the tangent lines to the derivative, to f prime, all of these tangent lines from negative infinity to 0 all would be positive, which means that that's telling me something about the second derivative, right? Because the slopes of these tangent lines would be positive. So I would expect the graph to be concave up here, and after 0 all of the tangent lines would have negative slopes. So from 0 to positive infinity, or at least the 4, the slopes are negative, and in that area I would expect this to be concave down. So I'm expecting a graph that's always decreasing except perhaps at 0, and it changes from concave up to concave down. So a possible graph then for this, if we just stay with the parameters of -4 to 4, because it's not real clear what's going on, well, this thing would be decreasing, and it's getting closer and closer to 0, getting horizontal, my tangents, and it's currently concave up, and then at 0 it's going to change concavity and still be decreasing, but now it's concave down. And this appears to be something like, again I don't know this for certain, I'm just, as an example, something like -x cubed, and so its derivative would be -3x squared. Right? All of this is just speculation. I can't really know this at this point. We need some other tools to know the equations, but the relationship should make some sense in terms of what we know about the graph. Let's look at one more like this time around. We'll consider D. Looks to be an absolute value graph. So on D, f prime looks something like this. This is f prime. So some things, it's always negative except at 1. So I would expect this original function to always be decreasing except when x is 1, because that's where it equals 0. Notice that this has a positive slope, this part, and so as that relates to the second derivative, I would expect my graph again to be concave up here, and since this has a negative slope, I would expect it to be concave down here. But it's not going to be a smooth change like the previous graph, it's abrupt. So let's say this is, it appears to be maybe +1, and this appears to possibly be -1, right? But it's just changing immediately from +1 to -1 as far as the concavity change. So if we sketch a possible graph here, it might look something like this. So it's decreasing, and the steepness is getting less and less as it's x is getting closer to 1, the slope is getting closer to 0, and now the function I'd be doing something like, the second portion may look something like this after 1. And some ways to think about how to make sense of this: the absolute value of x as a piecewise function, and that wouldn't be the absolute value of x, that would be I'm not even sure what that would be. let's just check this in terms of the derivative. So the values of the derivative, if we talk about it as slopes, start off at -5, -4, -3, -2, -1, and then end up at 0. And then they get steeper again, right? Going to -1, -2, and -3, and -4, and -5. So it happens to look very similar to what we just saw. We'll look at a few more examples like this in the final video for function analysis.